Hello, this is Paul from Foresight Tech, and this is the last part, the sixth part for hyperbola. In this part, I will show you what is the reflective property for hyperbola. Everyone. So I'll show you what is the reflective. Wait a little. What is reflective property? Reflective property of hyperbola. Okay, so everyone, I think you remember what is the reflective properties for parabola, for ellipse, right? So we should do. And here we're going to show you what is reflective properties for hyperbola. So I tune a little. So here the results, and then we're going to prove the results for you. So we get this. So I draw horizontal type. Okay, I draw easy one. And because the results is same for other type, if there's a y-axis, if there's a x-axis, put the center is at here, and then they put the one vertex, another vertex. Okay, so I draw the parabola. Okay, if I draw the hyperbola. Okay, so this is one hyperbola. This is the second branch, left branch, right branch. Okay, so I give a name. Here, if I give this is the center, so this is a V1, this is a V2. All we need is this F1, the first focus, the second focus. Okay, and of course I give this equation. And the equation is this, the standard equation. I give the stem to the equation for this should be this is a horizontal type, right? So should be x go first, x over a square, because the center is at here. Okay, so this time the center is 0 0, so x square maximum is 0 square minus y square over b square equals 1. We need to use this. Okay, we need to use this standard equation. And then what is the reflective property? And we do this. And suppose we have a point here. Okay, and if we have like a ray or a light ray, okay, or a light comes in this direction. So if I simply draw, okay, go to here. This is a light coming in from somewhere, like and then the direction, if we extend this direction, is a point to F2, and then go to this point. I have give a name of this point is P, is okay. So this P I have give a coordinate is x0 y0, and then this light will reflect. So where to go, the direction. Okay, so here, and the result tells us this light definitely will go to this direction, point to another focus. Okay, point to another focus. Okay, point to another focus. So can you see this? Okay, so one light in, and where to go? So we'll go to another focus. So this we call it the reflective property, and we need to prove this. So how to prove? Okay, so how to prove this? We need to know what is refraction. Reflections we need to draw. If I draw a tangent line, so I draw this small. Okay, this is a tangent line. I highlight. This is a tangent line. Go through this point P. This is a tangent. It's a tangent line. Remember what is tangent line? Tangent line is the line only touch the point and not a cross. Okay, and if it's a reflection, so we should follow this. And it goes to this goes to this direction, means that these two angles should be the same. If I give you an angle a name, this is alpha. If I give another name for this angle, is beta. Everyone. So all we need to do, this property is alpha equals beta, right? If alpha equals beta, and then this light goes in and go to this direction to reflect. We need to prove this now. We need to prove. We're going to prove is alpha equals beta. So everyone, so can you see this? So we're going to prove alpha equals beta. If alpha equals beta, this result is exactly true, right? What do we need? So we need 1 9, 2 9, and 3 9s. I have to give a name. Okay, the tangent 9 I give is L. The tangent 9 I use L. Okay, and the slope I use M to describe the slope. So this is a slope of the tangent line. We need to use one more 9, which is this 9. Okay, and this the light ray comes in. Or we say it's PF2. This line is PF2. I give this line, the name is L1. Okay, can you see this? I extend this longer. Okay, so can you see this longer? This is I give you L1. This is L1 with the slope M1. Okay, so I will going to find the slope later. So this light. So one is the tangent, one is L1. Another is this reflected light. Okay, this is a straight line, right? So this line, if I give a name, this is called L2. Okay, so L2 has the slope M2. Okay, all we need to use is one line, two line, one straight line, two straight line, three straight line. Okay, first, so why you going to get this slope, get this slope, get this slope, and this is easy. We get this slope first. What is M1? Okay, M1 the slope, we need to find the F2, right? So I put the F2. This point, 1 point P, 1 point F2, so we can find the slope. So F2, remember, is C0, right? So what is F1? I also put a negative C0. Good. And then I can find the slope for L1, which is P to F2. I use P minus F2. What is this? So we will get Y0 minus 0, which is Y0. X0 minus C, which is, so let me 2, hopefully, 2 and a little. Yes. So X0 minus C. So X0 minus C. So that's good. We need, this is important. This is M1. Important that we need to use. So what is M2? I put it here. M2 is, I use P minus F1. Okay, it's the same. The difference between Y0 minus 0 is Y0. X0 minus negative C, which is X0 plus C. Fine. This is M2. We need to find this M. So you don't have this knowledge, you need to go to calculus. Okay. If you go to calculus, I think someone know how to find it. We based on this equation, we can find that the slope means derivative of y at this point. If someone knows something, I will write it here. If you don't know this calculus, of course, you can forget it. Okay, you can ignore this part. If someone you know, or in the future, if you know, is this is the way you're going to find the slope for m. Okay, at this point. So I'm going to take a derivative to both sides. From here, take a derivative to x. So we have a 2x over a square minus. I take a derivative to x. Here is this is the chain rule. So we have a 2y determines y derivative, and then goes to b square. The right is 0. Of course, this point is x0, y0. So what I will going to do, I will put the x0 here and the y0 here. Okay, and then we're going to solve for the derivative. This derivative is the slope m. Okay, and this derivative is the slope m. So please keep in mind. So this m equals this prime. This prime is at this point. So all we need to do is solve for this. So how to solve? So we have a 2x0 over a0 equals 2y0 times this to here times y prime and b square. Okay, and then y prime I cross. Okay, so cross, what do we get? Y prime equals this. First I cancel 2 this and this we cancel. What we have is b squared times x squared, right? So I put b squared times x squared over y squared times y0, so which means a squared times y0. So this is slope, this is m. I put here is m, the first m. I put this one to there. Okay, so in this way m, the slope, is b square x square divided by a square y0. Okay, this is important. This is from calculus. This is from calculus. If someone learn calculus 1 in the future, please go back to look at it. Can you find the slope? Easy. Okay, it's very easy to find. So now all we need to do is what? We need to prove alpha equals beta. So we need to find the tangent alpha equals tangent beta, right? Is tangent alpha equal tangent beta? How to find the tangent alpha? So 2 steps. So here, how to find the tangent alpha equals how many? If we find the tangent alpha, all we need to do is like this. So we need to find the tangent alpha equals tangent beta. How to find the tangent alpha? Okay, tangent alpha is the angle between L1 and L from 10.1. So we shoot the formula, right? So how to find the angle between two straight lines? So here is what we need to use. So how to find the beta is the angle between L2 and L. So we can find it because we know all the slope there. Now what we left is to calculation. Tangent alpha is this. The formula is use tangent alpha is this line is m minus this line. This line is m1. Okay, m1 over 1 plus m1. This is the formula we learned before, and then we're going to simplify. It's a little bit of calculation. So here is what. Here goes to m. I put that. So we have a b square x0 over a square y0. Then minus m1 is here. Okay, so I put x0 minus c. Okay, what is the bottom? The 1 plus this term b square x square over a square y0, and the terms y0 x0 minus c. Okay, and then equals. Now we're going to do calculation. And what do we get? So I will get a long one, very long. Okay, so I will going to I do one more step for you. Okay, I put these together. Okay, I put these together. These are fraction, I put the fraction together. So here goes to a square y0 times x0 minus c, right? I'm going to combine the fraction on the top, and then should be this times this, which means b square x0 times x0 minus c, and then minus y0, right? Okay, so I say y0 times a square y0. This is the top. The bottom I also going to do compound. So this times this is a square y0 times x0 minus c. Okay, so this is 1, means the common denominator is the same. So we're going to copy this term, it's longer, which means a square y0 times x0 minus c. This over this is 1, and then plus this term. This term is b square x square times x0 times y0. Everyone, it's almost right. A little bit longer. And then can we look at divided means times the flip. When we times the flip, this term and this term exactly the same, so we can cancel. or would we left the top and the bottom? No, I put it here. So I put this one to here. Should be equal to this. It's the fraction. I will going to distribute it. So everyone, this I will going to distribute. We're going to distribute. Okay. So what do we have? Is b square x 0 square, right? So when we distribute it, then minus b square x 0 times c. I use c times x square. Okay, x 0, so it's the same. And then minus, these I simplify a little, which means minus a square and y 0 square. Okay, good. So what is the bottom? I also going to distribute it. Distribute it to the first, distribute it to the second. And then what do we have? So here goes to a square, right? And then x0 y0, I will use x0 y0 to describe. And the second term is minus a square. I use c times y0, okay? And then plus. This term I just copy b square x0 y0. Okay, going to simplify again. How to simplify? It looks complicated, but don't worry. And this term and this term, okay, I will put them together. I will put them together, which means what? So I copy this, put it here. So this term and this term I put is put a parenthesis is b square x0 minus a square y0 square. Okay, and then minus b square c x0. So what the bottom I also going to put something together. x0 y0 x0 y0. I put this term and this term together. So what do we have? So these together means factor x0 y0 together. We will have this a square plus b square times x0 y0. Okay, so this is d1. This is d1 we get it. This is d1 we put it together. And then minus a square c y0. Okay, almost. And how about this? So we need to go back to this equation. Okay, and do you remember? So this equation means what? P is on the equation, right? So I put here. Means x0 y0 per log into this formula, you should be satisfied. I put here a little x0 square over a square minus y0 square over b square equals 1. Okay, from here we can find something. And this is exactly related to this. At times a square, b square, both sides, what we get is b square x0 square minus, okay, you times a square, b square, both sides. And then we will find a square y0 square equals how many? A square b square. See, this is the one we need. This is exactly the one we need. I plug that one to here. Okay, we can simplify. What do we get? B square x square minus a square y square is a square. Okay, here is a square b square, very simple. And then minus b square c x0. And the bottom we use this. Remember ABC, the relationship. Okay, and a square plus b square equals c square, right? I use this. So what we get is c square times x0 y0 minus a square c y0. Almost. And then we're going to simplify. Or what we're going to do is to factor out something. Factor out the common factor, b square, right? b square. That's the only one. Okay, that's the only one we factor. Okay, so I'm going to factor. So b square, we factor here b square. And then what we left is a square left minus c x0. Okay, it's that top. What the bottom? So we're going to see we have one c and one y0. Okay, see, y0 and one c. Factor out. So factor out c times y0, and so left is c x0 minus what we left is a square, and put the absolute value. Everyone, don't worry. So this term and this term is the opposite, but when we put the absolute value, they goes to cancel. So the final one here, the simplest one now we get it is b square on the top over c y square. Okay, c absolute value I put it here, which means y square, put the absolute value. Everyone, can you find this? So I copy. Put it somewhere. This is the beginning. This is the end. I put this small box to here. What we get from this step is tangent alpha equals this number, which means b square over c, the y absolute value of y. This is the result for tangent alpha. Now I will going to find the tangent beta. You know it's the similar step. Don't worry, it's the similar. Just a few minutes. Okay, a few minutes. I will going to. What is tangent beta? So I'll put this a little bit. Follow all the steps. The same steps is okay, everyone. So what is tangent beta? Can we find? Here I will going to find the tangent beta. Okay, and the beta is the angle between L, so the tangent line. Beta is the angle between the tangent line and L2. Okay, tangent line has slope m, L2 has slope m2. So we use the angle between two straight lines. The formula we will find now is this. So this time is m minus m2. Almost the same. I will go much faster than the first. Okay, I plug in. What is m? Okay, put it here. M is the same b square x square over a square y0 minus m2 is there. y0 x0 plus c this time. The bottom is 1 plus b square x0 over a square y0 times y0 x0 plus c. Okay, and then the same way I did before, I'm going to make a fraction, a compound fraction. The fraction to the bottom is a square y square times x0 plus c. The bottom goes to b square x0 and then times x0 plus c. Then minus y0 times a0 a square y0. Okay, this is the top. So the bottom is this. The bottom is longer. Okay, is a square y0 and the times x0 plus c. And the 1 means a square y0 times x0 plus c. This over this is 1. And then plus b square x0 times y0. Okay, see, very similar. Okay, another step, you know, is going to cancel this term and this term is the same. And then we're going to simplify it by distribute, and this distribute, and distribute. See, what do we have for the another? Let me see. Almost the same, okay? It's almost the same. I think you can see, right? So now, these I will also copy to here. So equals what? Equals the absolute value. So the bottom cancel and the distributor, what we have is this term, b square. So we have b square x0 square plus b square c x, b square c times x times x0. And then minus y. I will use this. I will use a square first. Okay, a square y0 square. This is the top, but the bottom. After the distributor, we have a square x0 y0 plus a square c times y0, and then plus this last term b square x0 y0. Okay, and then going to do this way. So how do you combine? So they are going to combine this term and this term. Going to combine this term and this term. Okay, so everyone, you know this. Now we have what? We have the fraction b square x square minus a square y0 square plus b square c x0. The bottom these put together is a square plus b square x0 y0 and plus a square c y0. Okay, and the same. So this is equals how many? Or you can say, you can use the same. Okay, so the point P is on the graph, which means x0 over a0 minus y0 over b square equals 1. And then this means x0 b square x0 square minus a square y0 square equals a square b square. You cancel the denominator. What you need is this. So we used it before, right? So put it there. So I put this to here again. Let's go down. And now what do we have? So the top goes to a square b square, right? So I copy here a square b square plus b square cx0. The bottom, of course, the bottom we showed this before. Okay, a square plus b square equals the log c square. So we have c square here, x0 y0 plus a square c y0, and then to factor, so the same. Okay, so factor b square out. See the b square. So we factor the b square here, and then we left with a square plus cx0. Okay, put the opposite of the value. So the bottom going to factor the y0 and the c. Okay, and the c. So c y0 factored out. So what do we left here? So we have 1c x0, a square left. So now you see this term and this term is the same. We cancel, and then the final you have what? You have b square over c is a constant positive number, opposite value of y, and this is the end. This is the beginning. What do you have is what? So we get is tangent beta equals b square over c opposite value y square. Okay, so can we compare this to the first we get it? Can we see? Yeah, definitely, right? Are they the same? Definitely the same, right? So tangent alpha. Now what do we have is this. Now we get a tangent alpha equals tangent beta, means both accurate angle means alpha equals beta, both accurate. Okay, so we have, this is the final, and should we go back to here? And I hope you enjoyed. That's all. Thank you for this topic. Bye.